Using the fact that the derivative of sine of x is equal to cosine of x, the derivative of cosine of x is equal to negative sine of x, and that secant of x is equal to 1 over cosine of x, we can try to figure out what is the derivative of secant of x by using the quotient rule. Because again, secant of x is equal to 1 divided by cosine of x, so in this case we can write secant as a quotient, like this, 1 divided by cosine of x. So recall the quotient rule can be derived from the product rule, and the quotient rule says that all we need to do is take the derivative of the top, multiply it by the bottom function, subtract the original top, times the derivative of the bottom function, and divide all of that by the square of the bottom function. So let's do that. So the derivative of the top, the derivative of 1 times the bottom function, minus the top function times the derivative of the bottom function, all divided by the bottom function squared. Simplifying this, well, the derivative of 1 with respect to x is 0, so 0 times cosine, and the derivative of cosine is negative sine, so we have negative sine here. Of course, negative and negative become positive, so this becomes 0 plus sine of x, or just sine of x, divided by cosine squared of x. This can be rewritten as 1 over cosine of x times sine of x over cosine of x, because cosine squared is cosine times cosine. And what is 1 over cosine of x? Well, it's secant of x. And what is sine of x divided by cosine? Well, that is tangent of x. So this is just equal to secant of x times tangent of x. So therefore, we can say that the derivative of secant of x is equal to secant tangent.